I think recording was missed, right?
No, sir. You just go on. Sometimes due to network, it happens.
Oh, okay. I hope.
Yes.
Okay, so this one also you can use. So this will help you to do quick analysis. Okay, so you don't have to sometimes you don't have to do complete malware forensics. But as of now, the tool is not signed. So many of the antiviruses might flag it as suspicious. Okay, so you can use these tools as a malware analysis tool as of now. Okay, so it will find out anomalies and all. Okay, so now switching back to memory forensics. Okay, so this was live forensics, you can say. The live system I can do forensics. Auto runs also I can use for live forensics without offline. Memory forensics or is the other way where you can basically take the dump of the memory. That dump of the memory can be shifted to another system, and after that you can you do the memory forensics. Similar disk forensics and other things can also happen in that way. Like basically, you can image the disk and analyze it on another machine also. You don't have to remain on the same machine. Okay, same case of memory forensics as well. Okay, so how do we start with the memory forensics? So sometimes I see memory forensics used as a malware analysis tool. How? Because memory, as I told, if a binary is packed, then you can basically run the malware, and after that see the artifacts in the memory. Okay, so in that case you can do malware analysis as well. You can basically run the malware and basically after that extract the dump, and after that do analysis. This is an easier way, but there are certain problems with the easier way. Say suppose if you today your target your objective is to analyze some 100 malwares. Okay, so it won't be possible with memory forensics because it is going to be time taking and resource consuming also. Like for every malware you run, you have to take the memory dump. That would be almost 2, 3, 4 GB depending upon your system configuration. So, memory forensics is just a minute. Memory forensics is about extracting data from the memory. Memory forensics is mostly about running the process, get list of the process, get network communication, all these things. Okay, so uh, it can be used to analyze a malware already executed in case of incident response case, because in incident response or forensics, real forensics case, uh, you are required to analyze the infected system. While in case of malware analysis, you can execute a malware and then do memory forensics. Okay, so give many information like rootkit analysis, all these can be very easy here. Okay. So often in bare machine, code injection can be hard to analyze. Okay, but memory forensics make it easier. But my tool can help you. May not be in all cases, but certain cases definitely. Okay. So volatility also has false positive. My tool also has false positive. They both have similarity. Another thing is, as I told, memory, everything is visible. Okay, so it might not execute. Even if the malware doesn't execute, if you are able to retrieve a malware, even though if it is not executed completely, if you are somehow able to retrieve the memory of it by preventing the malware from executing completely, then basically you can extract the memory dump and do analysis. There you can extract the memory. In memory, you can see many things, even though malware is not executed. Okay. So what are the steps involved? First is memory extraction. Okay, so this is the first step of memory forensics. So from RAM, memory is extracted, a memory dump is created, and this memory dump is the source, is something with which we do the memory forensics. Okay, so in terms of malware analysis, you can have a virtual machine. Since you don't want to, since you are doing it in terms of malware analysis, what you can do is you can have a virtual machine also, which minimum processes running. Do not run all the tools. Nothing you should run. Okay, so only run the malware. After that, extract the dump. Run memory forensics. So memory forensics, how easy I'm going to tell you. Okay, but you should have understand the system. So memory extraction. So many tools are there, like TK imager is there, RAM capture, dump it, RAM capture, memorize. Okay. So these are very, very easy tools. Only thing is you need to click the button. So I don't want to show a demo of this. Only thing what you are required is to click the button. Okay. So here RAM capture is there, click the button. Okay, so I don't think any of the tools which are used for taking file dump or memory dump, those are very hard. If they have a UI, only clicking is going to help. Yeah, so you don't have to read also properly. So capture memory, you will see capture, you will save in certain location. Okay. So for better dumps, as I mentioned, you should have minimum process running. So should not use tools which are of no use. Yes, and uh, yeah, to avoid FPs in case if you are doing malware analysis, so how to avoid the FPs? So what you can do is you can take a clean snapshot before running the malware that you can use as a reference point, and you can analyze that as well. Keep know that what's happening, like what processes are running, what codes have been injected, all those things. So you can have a clean setup for just as a reference point. You can see like I took a clean memory also. So .mem extension are there. After that, I run the malware and take the malware snapshot. So all these are malware snapshots. Okay. So this can be used for a reference because all the all the tools throw false positives. So volatility also you will get false positives. So basically, clean snapshot is going to help you to figure out those false positives. So something you find suspicious on the malicious memory dump, if it is not there on the clean memory dump, that means it is suspicious. If that is also present in clean memory dump, that means that whatever you are seeing is not malicious. Okay, so you can compare these two. Okay, you can do a comparison, figure out what are malicious. That is one easy way. Okay. So many other tools have certain problems also. Like for forensics, we use a tool named Gmer that is obsolete, and now we have a tool known as AR kit, okay, anti-root kit. Okay. So that is also used, but those every tool has false positive. Okay. So there, the way to figure out false positive is also you have to know about the clean system. Okay, so one important thing. So whichever system you are doing forensics for memory or taking memory dump, you should know the configuration of the system. Why? Because that is something which would be input to the volatility tool. For an example, in order to take the information, get the information about the system. Like for an example, I was using the Windows 7 SP1. Okay, so x86 version, that means 32 version. So I run the system info command. It gives me that image info is uh, it gives me this information like Windows 7 Service Pack 1 x86. So basically, I would be combining this into this one, and this image info, this is a parameter to volatility command. Okay. So another problem. Say suppose you take a image. So volatility, how it works is basically it has defined data structure for different version of operating systems. Okay. So for example, Windows 7, there is a separate way in which volatility parses the memory dump. Windows 10, there is a separate way. Similarly, Windows 7, x86, x64, all have separate ones. In case uh, the volatility is not supporting this particular version of Windows, then uh, you cannot do anything with the memory dump. Okay, that's the problem. Okay, so the tool has to support. So volatility has support. So I tried this. I was not aware of this. So I used, uh, I think, a home edition of Windows 10 or educational version of Windows 10. And after taking the dump, I realized that volatility is not able to identify it. It is not able to do analysis with that. Okay. So maybe later they might have added, but this one thing I realized. Okay. So volatility basically you have to specify which all operating system you have taken the forensics image from. Okay. So that is very, very important. So let us see the volatility commands. Basically, there are some volatility images I have created for my book. Okay, so those are freely available. It is there in the Google Drive link. You can visit my book GitHub page and you can find it in module 14. Okay, or otherwise, I can share you the link also. So that from these on these samples, I can run the volatility forensics. Okay. For now, I'll do another one. So basically, there is a publicly available sample memory image there. So I'll be using that. Okay. So the sample name is Zeus. Zeus is a malware. Okay. Uh, excuse me for a minute. So Zeus is a malware. It did. I think the malware dates back around 2012 or something. Okay, so volatility. Somebody had created this image. The image name is Zeus.mem. Okay, so basically I use this image. There is why I use this is basically there's some documentation around this also. It would be useful for you to refer back. And so I will also be providing the. I cannot provide you this sample because it is very huge size. It's 256 MB. Okay, so I don't have a means to share this, but I can share these commands what I used. Okay. So provided if you know the things properly, volatility is very easy. Okay. So first of all, as I told, you have to know information about the particular image. Okay, so what I can do is the first thing I do is uh, volatility I run. So volatility, there is a standalone version. You can simply uh, run it. Minus F stands for file name, and this is the memory image name and image info. So basically, with volatility, you are asking volatility what should be the image information of this particular image. So let me execute this command. So if I execute this, it takes a some time to analyze the image, and after that suggest you something. Okay, so it has something known as KDBG. Okay, so that is something where database related to the operating system is there most likely. Okay, so it has few suggestions for my image, whichever I've taken. It is Windows XP SP2 x86, or it can be Windows XP SP3 x86. So the image was most likely this one, Windows XP SP2 x86. Okay, so this we would be using in the rest of the commands. Okay, so basically volatility has commands, and we generally it is termed as plugins. Okay, so basically if you want to see list of processes in the image, so this is the simple command. First you need to provide the file name, then the image name, then you need to specify the profile name which we got from the image info. The profile name is this one, and after that process list. So this is going to give the list. Okay, so let me run the command here. It takes a little while. Okay, so you can see all the list of the processes. Okay, whatever is running, you can list it. You can also see in a parent-child relationship with the tool known as PS3. Okay, so this is another plugin in volatility. You can use PS3. Okay, so it will show in parent-child relationship. So in case you have trouble looking into these commands, okay, so what you can do is you can redirect this to a text file and look into it. Okay, so you can put like test.txt, and after that check it. Okay. Okay, so you can basically look it like this. Okay. So I put in a text file, I redirected it. Sometimes looking into the command console can be hard. Okay, so you can just put in a redirect to a text file, and after that check it. Okay, so you can see here how the parent-child relationship is like this. Okay. So next is in this case we can start with uh, something with the network connection. Okay, so there are other tools as well, other plugins as well, like PScan. So this is force way to find out whether a process has been terminated or hidden with a rootkit technology. So rootkit is a technique in which the malware can hide a process or a file, its own artifacts. Okay, so PScan is another way to scan the processes. So basically, it looks like this. Uh, so I can show a screenshot uh, in my virtual machine, in my slides. So in my slides, I'm referring to another image. Okay, so it looks like this. So if you see PS3 in my case, or this is not the use image. Okay, this is another image. Okay, which is taken from my book. So basically here it tells that you can see things like this. So here is a sample, real malware sample. After it started SVC host, it basically exited. So when it exited, it told me something like this in PHP. That means the process already exited, but you cannot see in process hacker, but in PSX, PS3 too, you can see a process terminated. Okay. And its child is SVC host, and this parent is not services, then it's suspicious. Okay. So PS scan is another way. Okay. So PSX view, so it is a brute force mechanism to identify some hidden processes. So it uses the technique PS list plugin, PS scan plugin, and it tells okay certain sample is there or not. Like in this case, it says PS the sample process, sorry, the particular process is visible in case of PS scan, but not visible in the thread prop technique. Okay. So similarly, Volatility has other commands related to listing of DLLs and all. Okay, so DLL list all the DLLs. DLL dump list all the uh, dumps LDR modules, displays all the hidden modules. So okay, so we'll get back to the image, practical image. So here in this Zeus image, I'm again referring to the Zeus image here. So I'll start with somewhat with network connection. So I would be using the command conscan. Okay, so let me run this conscan command and see what happens. So I can see that conscan command result in this. It connects to certain IP address, that is remote IP address, that is 193 at port 80, and that is 856. Okay, the process ID of the process is 856. Okay, so let me check for this IP. So this is an old IP. Might not be there might not be any information about this, but still let's see. If you can see anything. So yeah, so it's only referred in some old things. So maybe in this here it is using some binaries there. So apart from that, uh, so nothing much here. So basically, if is it was a new, maybe you have got the IP reference in virus total or somewhere. Okay, so it was an active malware. Uh, so next is I know this PID is there. So next is I have to figure out the PID. Okay. So what I do is I run another command which PID is responsible for doing this. So I run this command. Okay. I've taken this. I have to find out which PID, to which process this PID belongs. So to find out the process, I can use the PS list and find str 856. Okay, so this is equivalent to grep in Linux. Equivalent to grep in Linux. Okay, so this will filter which process has this. Okay, so if I run this, you can see that it is pointing to the SVC host. Okay, so it is pointing to an SVC host. SVC host, anyway, this could be a suspicious ones. Okay, so if you check other things, it could be suspicious ones, or a injected code could be possibly there. Already, maybe in a running process, injected code could also be a possibility. Okay, so let us dig down into this. So assume that it is some injected code is there. I talked about code injection. Code injection is a way to in which using which the malwares can host malicious code from inside a clean process. So in Volatility, there is a plugin to find injected code as well. The plugin name is Malfind plugin. Okay. So if you do Malfind plugin simply, okay, if I do run Malfind plugin simply, so what it is going to do is it will try to find all the malicious injected code, okay, suspicious injected, which it suspects to be injected code in the entire system. Okay, so you can see lots of them. Okay, so many may be false positive. It will take a long time. Okay, so what I can do is I know that this is a suspicious process, so I can put a filter to it. Okay, so to the malfind command. So how do I put filter to a malfind plugin? So here I specify the particular process. Okay, minus P 856. Okay, so if I put here, it is going to show only the possibly injected code in 856 process. Okay, so if I run this, shows me possibly injected process things are there. So one of the things, if you see here, in a address whose address is B7000, there could be a exe file. Why exe file, executable file? It can be DLL also because it starts with MZ. Okay, so this can be a reason of suspicion. Another thing is its attributes are page, execute, read, write. Okay, that is RWX. Okay, as I told many times, injected code can be inside RWX as well. Okay, so this can be one of the places of suspicion. So other places, there can be other places as well, but this is, uh, as I told you, this shows you suspicion based on read, write, execute as well. So it is showing you other places as well, but the main suspect can be this one because it starts with a uh, MZ, which is a possibly injected code, injected DLL, or injected whatever it is. Okay. So what I can do is I can dump it to the disk also. Okay. So Malfind also has a option to dump to the disk. Okay. So basically, if you want to dump to the disk, so here is an option I can show you. Uh, Give me a moment. Okay. So to Malfind you, I don't have it here, I guess. Okay. To Malfind, you have to specify uh, the -D and the dump folder. Okay, then you can find it. Okay, so I don't think I've put it here. Okay, so another way to dump is volatility minus this thing. Okay, so I need to provide the PID. After that, which image, which image, which memory location I want to dump. Okay, so B7000, which I derived from here basically. Okay, so looking into the output, I can dump as well. So this is the region which I want to dump. So I can specify it. -B stands for base, -D stands for dump folder. So there is a dump folder which I can dump. So if I run here, okay, so if I run here this entire command, so I have a dump folder. If I show you, so here is a dump folder. Okay, so when I run the command, this memory is dumped there, and after that I can do an analysis with bin text. Okay, so I have already run the command. Okay, so instantly I'm running on my real system. Okay, so the defender is active. So as soon as I put the dump, it detected as suspicious. Okay, so it basically dumped the file here. It dumped the file here. So what I've done is I have already removed the file. Okay, so I'm not running it because it's not a .exe. It won't run all of a sudden. But as a practice, don't do it. Okay, so because you are new. So basically, I am doing a string analysis here instead of bin text I use here, and I see that in the string, in the memory string, there are few stuffs. Okay, like some things are like related to your network communication. Your user agent is there. Okay, so you can see here. After that, what you can do is you scroll down, you can see some more things going down. Okay, so maybe something this is filling during the internet. Okay, so these are something related to stealing. Okay, quick dot dat, sites dot dat. So the history dot dat. So these are in related to stealers. Okay, so basically Zeus is a stealer. Okay, so tries to steal history and something in some of the files. Okay, after that you can see some more things like there is a software known as total commander that is used in the system. Types your FTP software are there. Okay, so basically it is trying to steal information from all these different places. Okay, so there is a smart FTP, its favorites, it will try to steal. Okay, so all this it is doing. Okay, so basically Zeus is a stealer. So how do you identify the family of the Zeus? So again, here a mutex can help you. So okay, so there volatility also, there are other commands like you can list all the modules also. So whatever modules are running, you can list the modules, you can dump modules to the disk as well. Okay, so many commands are there. So volatility, if I want to see the mutex, mutexes. Okay, so basically, in order to see the mutexes, I have to see the handles there. Yesterday I showed mutex is a part of handles. So how to see the handles? So if I run this command till here, so your entire system handles would be dumped, which I don't want. Too much data would be there. So first is I want to list all the handles which belongs to this process, which I can do by minus key 856. So this lists me the handle. Now I want only the handles which are basically mutex. So if I do find str which is equal to grep and do mutant, I can see the handles. Okay, so if I run this command here, so I see some of the mutex. In this, some of the mutex may be generated by the system. Okay, so you need to figure out like what are all these mutex look for. Okay, so this is one of the mutex. This is Avira 2108. So this was used by Zeus memory, Zeus malware. Okay, so maybe now it is a old malware of very old malware. So maybe you might not get much information, but still FortiGuard Labs tells about this. Okay, so it belongs to Zeus. You just do a search there. Okay, so some information is already there. So also this Trend Micro also tells some old reports would be there. Okay. Uh, Somebody did with this uh, this memory dump only, so that's why you are seeing this as a mutex name. Okay, so you'll see some information if you are able to figure out all the things. Okay, but the genuine one of the genuine information is this one. So it is originally it was created by FortiGuard Labs, and it uses the mutex. It directly tells. Okay. So this is when you create a report. So this is an automated report. Okay, so in automated report you see like this what all mutexes are created. Okay, from strings it finds out all these things. So all this information you get. Okay, so this is the process of doing memory forensics. Uh, I'll stop here and I'll wait for the questions. So I can share this directly with you guys, the commands. So there are many more commands as well. Okay, so you can check the volatility site itself. Volatility is a free tool. You can download it. There is a volatility workbench also. Okay, but I don't think it works very well. So if I can share it here, maybe that would be helpful. Or I'll share with Vikas sir. So
Sure, sir. You just share with me. We will upload it on the LMS.
okay, okay, fine. Yes, any question?
Participants, if you have any question, kindly put it in the chat box. So I think there are no questions, sir. Uh,
Okay.
okay,
Useful for you, or you guys knew about it already?
okay. So if you have any doubt, you can put, or otherwise we will close this session. We will be starting with the next session. Uh, so, sir, I will request you to share those PPTs to the extent whichever will be possible,
Yeah.
so that we can share it with the candidates.
Okay. Okay.